In this video, we'll discuss the fundamentals of measurement. Now, when we're measuring, we're trying to find some size or quantity or amount, and often we're using an instrument with standard units, or we can measure by comparing it to some other known size or quantity or amount. When we talk about units, those are fixed references of an amount of some quantity. Now, what do we mean by all this? Think about measuring a child. When we do that, we often will use an instrument like a tape measure. And on most tape measures, you may be measuring in inches, or some places they measure in centimeters. It just depends on what unit they want to use as the standardized unit. Now, when we measure, we need to maintain that unit through the complete measurement. We don't want gaps or pieces left out, and every single part of that unit has to be the same throughout the measurement. Let's say we have a worm here we want to measure. One option would be to use a ruler, and here it is measured in inches, and they're even broken down to eighths of an inch. Each one of those tick marks is 1/8 of an inch to the next tick mark, so it's standard. So if I measure it, I could see from beginning to end that this worm is 6 inches long. Now maybe I don't have a ruler with me, but I have some unit blocks with me. I could take, and as long as the unit blocks are all the same length, I could put them side by side, no gaps, and say that the worm is 6 blocks long. However, it's important that there are no gaps. This would not be measuring the worm because we don't have those pieces there to tell us how long the worm is. This also would not be measuring the worm because they are not the same size blocks. To measure, it all has to be the same unit through the entire measurement. Now, in the US system, we're basing off the old world English imperial units. So we have lengths and areas and capacities and weights that sometimes feel very weird. Like, why is a foot 12 inches? Well, it has to go back hundreds of years to figure that out, but it's what we use in the United States. So it's important that we recognize some of these relationships. My suggestion is to make sure you have these units available to you as we're doing different activities. Now, the other primary system is the metric system, and it uses all base 10 relationships, going all the way from nano to giga, so the very small to the very large, and it's all based on base 10, which makes it a lot easier to work with. Again, we're dealing with the same types of measurements, but think about it. 1 meter is 100 centimeters, makes a lot more sense and is easier to understand than 1 inch or 1 foot is equal to 12 inches. Now, we also have to recognize relationships between these systems. The 3 most common that will help us go through any type of conversion is that 1 inch is equal to 2 and 5,400 centimeters, 1 gallon is equal to 3 and 7,900 liters, and 1 kilogram is equal to 2 and 2/10 pounds. Now, if we need to do exact conversions, those are the 3 we have to use. But we can also estimate at times to help us out, recognizing that 2 inches is close to 5 centimeters, but it's a little less. A yard is close to a meter, but it's a little less. A kilometer is about 6/10 of a mile, but the kilometer is a little bit more. A quart's a little under a liter, and 2 pounds is just a little less than a kilogram. They're close, but they're not exact. But depending on what we need, that could be good enough. For example, we talk about 5K races all the time in cross country. It's one of the sports that you see in high schools and even in the Olympics. And that is really close to 3 miles, but it's a little more than 3 miles. But it at least tells us an idea of how far we'd be running based on the US system. Now, there are 2 ways that I can go about converting when I need to do exact conversions. One of them is using proportional relationships. Here, I'm going to take and construct proportions one at a time using the direct relationships. And so I may have to do multiple proportions to make this happen until I get to my desired unit. The big thing is I need to make sure that as I set up my ratios in each proportion, that I am aligning the units. So let's look at the idea of converting 20 inches to miles. So if I think about the relationships I have, I know that there are 12 inches to 1 foot, and there's 5,280 feet to 1 mile. Those are the direct relationships that I know. So I'm going to start with the first one. Let's convert the 20 inches into feet. So I know if I use my ratio of inches to feet and inches to feet, that's 12 to 1 equals 20 to some unknown. I can then cross multiply, and then I'd have that 12 inches times the unknown equals 20 inches times 1 foot. I divide both sides by the 12 inches, and that allows the inches as a unit to simplify to 1, leave me just with the number of feet I have. And when I simplify 20 over 12, I get 5/3, or 1 2/3. Knowing that I have to do more proportions, I find it easier to leave it in the improper fraction form. Now that I have it in feet, I can convert it to miles by using a ratio of feet to miles equaling feet to miles. So I know that 5,280 feet equals 1 mile, or to 1 mile equals the 5/3 feet to some unknown number of miles. So if I cross multiply, and then I see I divide both sides by the 5,280 feet, again, my feet will simplify to 1, leave me just with the unit of miles, which gives me about 1/3,168th of a mile. And if you want to see it as a decimal, here is that decimal value, and you can see it's really, really small. So 20 inches is 1/3,168th of a mile. Now I said there's two ways. The other way that I can do conversions is called the chain of movement. And really it is doing proportions, but it's doing it as expressions that simplify the units along the way. So what I want to do is I'm going to use fractional relationships to convert. Again, we're looking at ratios and trying to simplify units along by multiplication. So if I think back to my example of the 20 inches to miles, if I think about where I'm starting at inches, then I need to go to feet so that I can get to miles. And it's going to follow the same proportion relationships. I just have to think very carefully as I do it. I start with the idea that I have 20 inches over 1. And again, it's 20 over 1 because that's changing a whole number into its fractional form. Now, I need to simplify inches to feet. So if I think about when I multiply fractions, I want my inches in the denominator and then my feet in the numerator, and that will leave me with a unit of feet. So I know that the relationship is that it's 1 foot to 12 inches. And when I do that, it'll simplify the inches and leave me just with feet. I need to do the same thing now with feet to miles. I want miles in my numerator because that's my final unit, and I want feet in the denominator to simplify out the feet. And that will leave me then with exactly how to multiply through my fraction. So I had to do 20 times 1 times the 1 mile divided by 1 times 12 times 5,280. And this will leave me with 20 over 63,360 of a mile, which simplifies again to the 1/3,168th of a mile. So again, 20 inches is 1/3,168th of a mile. It doesn't matter whether I go and use multiple proportions or I use this chain of movement. I just need to use a method that accurately pays attention to the units as I do my conversion.